Hello and happy Friday. I'm Brady Volpe, and today's session is a little different. We're talking fiber instead of coaxial cable, so we're changing things up a little bit. After our last live stream on PTP-less vCMTSs, Andrii Vladyka from Harmonic reached out and said, "Hey Brady, want to try something cool with fiber in the lab?" Of course, I couldn't say no. So he sent me an SFP and an ONU. That's an Optical Network Unit. And today, we're going to show you how I turn my vCMTS into a dual CMTS and OLT. So now I've got DOCSIS and PON network up and running in my lab. So if you're a cable operator, engineer, or just fiber curious, stick around. The demo is coming up fast. But first, Andrii and I are going to break down how this works, why it matters, and what it means for the future of broadband networks. Andrii, welcome back to the show.
Hi, Brady. Happy to be back.
Good to see you, Andrii, and it's my pleasure to have you back. For our live viewers, please do drop your questions in the chat, and if you're viewing the recorded version of this, drop your questions and comments below. We'll be sure to get to our best to answer them. So, Andrii, I think before we get into the meat and potatoes of the show today, we should probably talk briefly about what an OLT is for our viewers who may not have encountered one before, especially on this channel that tends to focus mainly on DOCSIS. So can you help me define just what is an OLT?
Absolutely. To define what OLT is, I think it's easy to start with analogy in cable. In cable, we have cable modem in customer home and cable modem termination system in operator's facility. So cable modem termination system manages all the aspects related to the cable modem, and it's essentially an access concentrator, right? So following that analogy, in fiber and PON networks, there is an access concentrator called OLT, Optical Line Terminal, which manages and terminates the connections from ONU, or, well, there are different terminologies. You can say ONU, Optical Network Unit, or you can say ONT, Optical Network Terminal. There is a difference between two of them, but let's not get into terminology right now. One crucial difference between the DOCSIS networks and fiber networks is that all the connections between the OLT and ONU are passive. There is passive fiber tree between the OLT and ONU. There are no amplifiers, so you can think of it as node plus zero in the latest and greatest evolution of DOCSIS, when there is a remote PHY device and then there is a passive HFC plant and the cable modem connected to it, so there are no amplifiers in between. I have to add that the fiber, this PON technology is not a new thing. It's been around for decades. What is new and innovative that we are showing here is how easy it is to add OLT into your existing DAA setup with DOCSIS.
Great. So that's super helpful. So the OLT is kind of like a CMTS, and the ONU is kind of like the cable modem. And what I liked, I think, and that's why a lot of people like the maintenance on passive optical networks, is there's just fiber, no amplifiers or anything like that connect the OLT to the ONU. So ideally, a lot less maintenance, a lot less problems that we typically have in our DOCSIS networks.
And a lot more bandwidth.
And a lot more bandwidth, which we'll see when we do the speed test coming up shortly.
Right.
So I think what I want to do is pull up one of these slides here. This slide here. So this is kind of, and thank you for sharing this slide, because this helps our viewers understand what my vCMTS looks like before I did the upgrade. And you were just talking about this earlier, how I have that replication in my CMTS. There's actually 3 pods in there. So if one pod goes down, I have that redundancy in my CMTS.
Correct.
And then after I did the upgrade, and I'm going to play a video here in just a second of me doing the upgrade in the vCMTS, if I can get this slide to advance for me here. after I did the upgrade, that gave me this OLT pod over here in blue. And I also know you did some configuration, which you may talk about. There was some BNG routing. Can you explain to me here what the change happened after I did the upgrade? I'll show that video in just a moment.
Yeah, sure. So two things need to happen for, as you said, vCMTS to become also a fiber platform. And the way we look at it at this ecosystem is there are PHY devices out there in the field, and PHY devices may be supporting DOCSIS, they may be supporting fiber. And whatever we run on a server, it's those applications, they really enable those remote PHY devices in the field to work. So the starting point when you had only vCMTS pods and management pod was where you had no fiber configuration applied to your vCMTS server, to your COS server that run only vCMTS. Once the dozen or so commands that I sent you over the email were applied to that platform, it automatically instantiated all the containers and pods that I needed to manage this remote OLT in the RPD and provision the ONUs with your existing provisioning setup. And there are also components related to data plane that can help to process your CPE traffic. When you run a speed test, it goes through the VBNG.
Right.
So that's a kind of what happens on the core side. Yeah.
Okay. Well, let's go ahead. So thank you again for sending me the SFP and the ONU. Let's go ahead and run the video of me installing the SFP. Here we go.
All right. Hi, folks. What we're going to do today is we're going to turn this Pebble RPD, this is a shelf RPD, which right now is just supporting DOCSIS 3.1. We're going to turn it into an OLT. We're going to do that by using this spare port right here, currently unused, by plugging in this SFP, so small form factor pluggable, which has an optical port here right into there. And this will turn this into a dual CMTS and OLT. We're just going to plug this in. It's plugged in. So now we have an OLT, but we got to plug optics into it. We're going to plug the blue side in. I'm not going to clean this because these connectors were already clean. I just had a dust cover poured on it. Right. So that connector is lit. I don't want to look into this side here because we have light coming out of here now. But I'm going to take this end here, which runs to my lab. We'll be in my lab shortly. And this side goes into the ONU, or the optical modem. So we are connected up. We have now the ONT here going to the ONU, feeding it with roughly 100 feet of fiber. This is 100 feet of fiber here, plus this small cable. That's it. There is some configuration here, which we'll talk about during the live stream. Thanks.
Yeah, so that was so easy to upgrade that RPD, and I think I called it a Pebble, but it's actually, the shelf is actually called a Wave. Is that correct? The terminology, or did I get that wrong, or is it still a Pebble?
Well, I'm glad you were able to memorize our terminology. This is good. Second, you're absolutely right. The 1RU version of RPD is Wave, and it has up to 3 slots depending on how many power supplies you want to use. You can have like 2 or 3 units in 1RU. The interesting part about that is that the shelf-based Wave is exactly the same hardware and exactly the same software as node-based Pebble. So by calling Wave a Pebble, you don't really make a mistake. It's just a form factor. So hardware and software-wise, feature-wise, they're completely identical. Yeah, maybe some difference in power levels, but that's not material for this discussion.
Yeah. So I mentioned that I have that fiber running into here, so that this is the fiber that's connected to that device, and then this is the modem itself. That's this little I got a lot of light shining on me, so it's kind of difficult. But so you have fiber coming into it, a cable modem, you'd have coax coming into it, and then we have Ethernet that runs into the computer that's sitting right here in front of me near the computers. You guys can't see that, but right here's, I actually have a laptop. And we'll be doing the demo off the laptop. I have a little 5 gigabit per second dongle plugged into the laptop here, so we'll run a speed test in just a second here. And if we can pull up the next slide, please, Mia. This, I think, is what you were referring to. So you, Andrii, we in the device that goes into a fiber node, we could do that same thing. We can plug that same SFP that I plugged into the rack mount version, and then we would be able to, out in the field, as an example, run fiber to you could run like a single fiber-based modem to a business subscriber, or if you had a residential subscriber that had some business running in their home, like myself, for example, that wanted this capability. I think that is what excites me about this technology, is you could have a lot of DOCSIS modems around, but if you wanted to extend fiber to someone who needed really high speeds, this is a way that you could quickly and efficiently do that, correct?
Exactly, and what is shown here on the picture is the compact version of our node that serves better for MDUs. But there are different flavors of nodes that have the same kind of Pebble RPD. And you're absolutely right. The whole point is that to add a fiber capabilities to this DAA DOCSIS node, what needs to be done is technician needs to climb up the pole with this SFP plus based OLT in his front pocket, and then slide the SFP in, like compare it to carrying 40 pounds box up the ladder on a pole and installing it and splicing it. That's just, unbearable.
Yeah, it's a totally different thing. You saw what I did in the lab. It was so simple. I loved it. It was easy.
Exactly. And then, yes, you still need to have the last mile, the fiber drop that goes to customer home. It has to be done. That's you cannot get away without it. But in terms of outside plan, the work that needs to be done in the outside plan for upgrading your DAA access network from DOCSIS to fiber, that's pretty much it. Just slide in one SFP into the unused RPD port and apply a dozen of lines in the existing CMTS configuration. It's not CMTS, it's platform configuration to instantiate all the pods and containers to manage that SFP in the RPD.
Yep.
That's the idea.
All right, so now we want to do a quick speed test. So I've got my laptop plugged into the cable modem. Again, I bought a $35 5 gigabit per second dongle off of Amazon.com. I found out that so I'll run the speed test here. I'll show you the results. The downstream speeds over 4 gigabit per second in the downstream. Upstream speeds are not so great, but that's limited by the dongle. I found some reviews about that. So we get about 1.4, and it kind of goes back and forth on that. And that I found is a limitation of the dongle that I bought. It almost seems like they designed these 5 gigabit per second dongles to work really great on the downstream, but not so great on the upstream. And I think that's what people are going on. They're kind of bursty. So now we got a full, almost 4 gig. You saw that kind of bounce up there on the upstream, but I can't seem to get consistent upstream speeds on these dongles. I get consistent downstream speeds on it. So that's not a limitation of the modem itself. In your experience, when you have, as I need to get a 10 gig dongle to get good speed tests, what is your experience with these modems when you have good hardware to test the speeds on them? What should this be capable of, Andrii?
The capability of the XGS-PON technology is if you enable forward error correction, which in practical cases almost always enabled, that's north of 8 gigabits in each direction. So you can get like 8.5, 8.6 gigabit per second in upstream and downstream symmetrical. What operators do with that, we see operators selling up to 5 gigabit symmetrical speed tiers from this from this technology. And you certainly can do symmetrical gig. Any kind of speeds that are marketed by fiber operators in the area can also be achieved by this solution. So cable operators can now compete easily with fiber providers.
So shout out to Carlos Lopez. He says, so would that port then feed a fiber splitter network so that it could feed multiple customers? Also, is that XGS capable? Thanks. So he raises a very good question, and I want to point out, first of all, we have a 20 dB attenuator going into my modem. And Andrii, maybe you can explain why I have a 20 dB optical attenuator going into my ONU.
Well, this question brings few topics that we need to cover before we answer the question. Number one, yes, 20 dB is a must. You cannot, please do not connect ONU to OLT with direct
directly.
fiber. It will, with high probability, damage optical receiver, potentially completely damage, make it unusable on one side or the other side. So please don't do this ever. Always put either a splitter with a high enough split ratio or an attenuator like we did in Brady's lab. And you can put something in between 20 and 25 dB. It will work fine. Don't put 30. It's probably too much. So that's number one. And number two, you may notice from the Brady's video that the connector that went to the OLT was blue, and the connector that we have at the ONU is green. So blue to blue and green to green. Do not mix blue with green because they have different kind of.
Well, the blue one is APC, which is angle polish connector, and the green one is APC, which is angle polish connector, and the blue one is UPC, which is a flat or ultra polish connector for UPC. I think that's what the blue one is, correct? And if you put an angle and a flat together, I can't do it on camera. It's all reversed. If you put an angle and a flat connector together, you will actually damage the connectors themselves.
Exactly. It may work for a while, but then if you unplug and plug them enough times, eventually you'll start getting like signal loss there,
yes.
and they won't work. So now back to question. Yes, normally there would be an optical splitter like that SFP-based OLT would have a fiber, and splitter can either be concealed within the fiber node, or it may go as a PON tree. There is no difference between a regular PON network and what we are showing here on the passive side. So yes, the splitter will be either within the node or it will be distributed along the way as the fiber goes along the neighborhood. And this technology supports up to 128 ONUs, up to 128 customers from a single port. We normally see operators connecting 32 or 64 split. That's what happens in practical life, but you can have up to 128 customers on that single SFP port just fine. And this module is XGS-PON capable. It also can do 10G EPON, which is a different standard, but you get roughly the same speeds out of it, different type of ONT. So if you're in 10G EPON camp, you can do that as well.
Yep. Awesome. Thank you. Jeremiah D says you would need to have extra bandwidth after the RPD RF configuration. Is there bandwidth control rules for the PON interface?
Absolutely. This is a very insightful question. I'll try to answer it in a concise way so we don't open like a can of worms, which will last for hours. The RPD has an embedded switch which has like queues, priority queues. And normally what would happen is that you would prioritize some of the sensitive DOCSIS traffic in the high priority queues on the RPD, and then you prioritize best effort traffic into the lower priority queues on that switch. When we add PON, you're absolutely right that 10 gig uplink from the RPD to the first switch in your head end is shared between DOCSIS and fiber. And that's where we have those priority queues in the switch. They configure it accordingly, so you don't drop high priority traffic when high volume, best effort, low priority PON traffic adds into that link. So we kind of drop low priority traffic first. And second thing, if you remember the slide that Brady showed with VBNG, there is a VBNG that runs on this server that helps us to kind of shape and rate limit the traffic that goes back and forth between the CPEs and the remote servers. So that also comes into play. BNG does certain kind of shaping and rate limiting and pacing of traffic to help the RPD side to deal with it.
Excellent. And then another question from Benjamin MM. He says, does the XGS-PON have a TV output? And what is the output in dBmV?
You can mix. That's something outside of my wheelhouse somewhat. You can mix analog TV signals with PON, to the best of my knowledge. Whether it's part of that solution, I don't think so. There are options how to do it. We have at least one example when folks in MDU market did it. But that's quite peculiar. It's not a mass market solution. So if you want to know more, I guess hit me up on LinkedIn. We can have a focused discussion on that. I'm not ready to answer it right away.
Okay, thank you. Great questions, folks. So I want to go to back to my screen here and show. First, I want to do show cable. Whoops, if I can type here. Show. I really can't type. Show cable modem. Modem. So here are my 16 cable modems online today. Normally, yeah, I think I have 16 cable modems. So this is the DOCSIS, showing that this is a running DOCSIS on here. All my DOCSIS modems that are right over my right-hand shoulder here. But then we want to show that. I guess we'll first show the PON OLT. How about that?
Yeah.
So here is if you remember me, folks, if you remember me plugging that SFP in when I was back in the other room. And by the way, that's a very noisy room. That's why it's in a different room with the fans blowing. So this is the ONT, and I guess, would this be the SFP that I plugged in, the model number of that? Is that how we determine that, Andrii?
Correct. That's the part number that if you take it out, the part number on the sticker on the SFP should be the same as what you see here.
Yeah, and we put a link in the YouTube video in the description if anyone's interested in seeing that to Harmonic's site. Just if you want to know the hardware that I plugged in, there was a link to the SFP. Then I think we want to show cable. I type much better when I am not on a live stream, folks.
That makes two of us.
It's the pressure. So,
right.
so tell me. So, showing cable RPD, what does this tell us?
So, this command output, if you look on the first column, you see the virtual chassis, virtual slot. It's 1:0. So that's coming from the configuration. And now if we and then there is an RPD MAC address, an IP address that it got from the DHCP server. Now, if you look on the output of the previous command, shown PON OLT, you can see that it has the same virtual chassis and virtual slot, and the number 2 means that it's the SFP is installed in the port number 2 of your RPD. That's how you connect OLT to RPD. So RPD 1:0 has an OLT in port number 2. And that's it.
Excellent. Now I know. So what's the next? I know you told me there was another command, and I forget it already. To show is it show PON ONU? I think.
Yeah, you can do show PON ONU, and we still have show cable modem output visible above. So here we can kind of compare in show cable modem output. There is familiar like things like the downstream RF port and bonding group, the upstream RF port and bonding group, and then modem capabilities in terms of bonding.
Modems
and the serial
online, yeah.
Right, and it's very similar. We did it very similar for show PON ONU. So it's like you see which PON port it's connected to, what's the MAC address of the ONU, what's the serial number, what its state, and how many CPs behind it. So it's very similar to how it looks in cable, and I hope that cable engineers who deal with CMTS normally will have there is not much of learning that has to be done to master this technology. It's very easy.
Pretty easy to interpret. Yep.
Right.
So then if I want the details on this modem, how would I see that?
The same way how would you do how you do it for cable modem. So for cable modem, you do show cable modem MAC address verbose, and
just
then I need to add the serial number or the MAC address of the ONU. It will accept.
And then verbose.
Right.
And there we go. All the details.
Right, and
it's been online 22 hours. Yeah, so the only reason it's been online for 22 hours was yesterday I pulled out the SFP and made the video of me plugging the SFP back in again, so we rebooted that. And here's some additional details: your bias current, the optical transmit power, optical receive power, your voltage, temperature, distances. Also provisioning, that was really important. So I didn't have to make any changes on my DHCP server, not even to the configuration file. So my modems and my cable modems that I run in my lab, I just uncap them, right? Because I run speed tests without being limited. This the config file that I'm sending is called new.cm. I think we can see that somewhere in here, right?
It's actually a different command.
Is that okay?
It's show PON vCM. It's exactly the same as what you just typed. Just replace ONU with show PON vCM and then serial number and verbose.
Yeah, because I remember seeing that. Right, so here's the config file, and that's the really nice thing. I didn't need a different provisioning system in order to bring this modem online. I could just use my existing provisioning system. We see the all this max traffic rate, max traffic first, quality of service. All of this is coming from the existing DOCSIS provisioning system is now provisioning my ONU, or all the other ONUs that would be on the network. So that was very easy to do, which for me in my lab makes it a lot easier. I don't need another provisioning system. Jeremiah D says, can you daisy chain the RPDs to extend the link range? 160 kilometer OLT deployments without EDFDA sounds nice in special cases.
Yeah, you can. You can daisy chain RPDs. They support MSTP protocol for that. So you can daisy chain. You can even have a loop. Like you can daisy chain them in a loop and connect the last RPD to the switch again, and then you'll have a nice loop. If you break it anywhere in the middle between the RPDs, you'll still get service on all RPDs. So that's definitely possible. Now for daisy chain, for deployments like that, there is actually an even better solution. There is a remote switch in the RPD form factor. So depending on the type of node you have, if your node has 2 slots, you can put RPD in 1 slot and the remote Ethernet switch, which supports 10 gig or 25 gig ports in the other slot, and feed your other RPDs from that remote switch. So there are multiple options for daisy chaining, including what you just asked.
So I think something that's important here is this is not a harmonic only solution, because I asked you about compatibility and you sent me a slide. I'd like to pull this slide up while we talk about, while you talk about compatibility with other vendors, because this is important, because it can't be just something that works within the harmonic only ecosystem.
Yes, exactly. And this picture is taken. I took it at Angacom trade show a few months ago, and thanks for stopping by the way. It was great to see you at our booth.
Likewise.
I hope you can visit us at upcoming SCTE Tech Expo. What that picture shows is a dozen of ONUs from different vendors connected to the OLT live. So that goes back to one of the first questions, like there's a splitter behind this wall, and it's just concealed from human eyes. And the fiber from the OLT goes to the splitter behind the wall, and then splitter feeds the signal to all 12 ONUs on the wall. And they're all live. There is a switch and a traffic generator again behind the wall, and all of them run the speed test in round robin fashion, and you can see the output of the speed test on the small screen on top of it. So the point of building this wall, I love it. One of our colleagues here in San Jose office suggested this idea, and we built it in a few months. I love it, but I also think it's not representing the situation well enough, because there is not enough real estate. It's only 12 ONUs. In fact, we do much more. Like there are dozens and dozens of ONU that we interop with. And this is the critical point, because that allows you, if you have an open system where an OLT can be connected to, it's the other way around. An ONU from any vendor can be connected to an OLT. That gives you a flexibility in selecting your ONU providers that frankly didn't exist in reality until recently. Normally, if you look on the PON deployments that happened in the last couple of decades, it's the same. Whoever provides an OLT, they also provide an ONU, and the other way around. So seeing that is something new to the industry. We heard a lot of talks about open ONU, but that's like real work in real life. And the ONU you got, by the way, it's not even on the wall. So it's on top of that.
My ONU is made by Zyxel. I think I'm pronouncing Zyxel or Zyxel. I think something like that.
I would say, in English, I would say Zyxel, yes.
Zyxel, yeah.
Yeah.
So.
And I think it's I think that let's leave it like that. So it is an open system, and the OLT that you put in a wave shelf is interoperable with other ONUs. I have to add here is that the interoperability is not something that happens automatically. Like you bring any ONU from eBay and it comes up. It may work, it may not. So there is a certain interoperability process that happens for every project that we take. And depending on the situation, on the level of cooperation we get from the ONT vendor, it may happen very fast and smooth. It may take some time, but it's doable. We were able to do it so far. I think that's it.
I do. I mean, just to remind everyone, just last week, this vCMTS was just running DOCSIS modems, and now it's running PON modems. And again, I didn't have to change my DHCP server. It was just a minor upgrade. So that, for me, this is exciting because now I have PON running into my lab. When I think about it from an industry perspective for cable operators who, again, they have a DOCSIS network, but they have customers that need maybe more capabilities or a lot more speeds. Like what he showed on the wall, so you must have 10 gigabit capabilities. I only have 5 gigabit capabilities. That was showing 8 gigabit down, over 8 gigabit down, and over 8 gigabit per second up. There are a lot of businesses, if you think like Starbucks or something like companies like that who need a lot more speed, but they only have cable passing them by. You could easily sell them a whole lot more speed than what you could give them with a cable modem, and that's guaranteed downstream and upstream speed. These are opportunities that I get excited about because as a cable industry, we can immediately compete with fiber competitors, and that is a great value proposition. And just by dropping an SFP and making some small config changes on the vCMTS is very, very exciting from my perspective. I don't know if you're getting the same feedback from customers or not.
we do, and there are more to add to that. So the use case you mentioned with businesses is absolutely valid, and that's one of the common use cases. There is another use case like a node split. Let's say typically on a typical node, you may get a few power users that congest your upstream and maybe even downstream, depending on your frequency plan. So and everyone suffers. Like few power users congest the entire upstream, and then no one gets enough bandwidth. So by offloading those power users proactively to fiber, a node split can be delayed. Suddenly you put a fiber, you give that customer proactively for the same price a symmetrical gigabit speed. The power users get all upstreams they can use, all upstream bandwidth they can use, and the rest of the population of customers on the same node suddenly get a relief on the upstream congestion. So that's another common use case. Another case is the time to market. What needs to happen for a cable operator to enable symmetrical fiber multi-gigabit speeds in a DOCSIS node? It's really fast. Literally sliding SFP and doing the last mile drop to the customer. From inside plan standpoint, there is zero equipment needed. Apply configuration to the existing COS cluster, which means that operators can start marketing high speeds, symmetrical speed tiers, pretty much in their entire footprint when they already have DAA deployed, DOCSIS deployed with DAA, and only put those SFPs surgically where the demand exists. So you don't have to upgrade your entire network to start selling multi-gigabit speeds. You can start selling them and then upgrade only the portions of your network where you see the demand. I think that's quite unique.
Yeah, I love it. It's cool technology. So I'm not going to try to pronounce this user's name, but they say, I work on enterprise IPTV and broadcast systems by day, but follow, do we have a follow-up? Well, thanks for following. Kai S says, is the Zytel, and I think it means the Zyxel ONU running DOG, or is its presence on the CMTS masqueraded as a DOCSIS modem with a DOCSIS TFTP config, e.g. QoS SCNS? So how would you, so is it masqueraded, I think, is that's the question.
Keep it. If you can keep this matters. Okay, beautiful. Number one, I don't know what DOG is. I'm sorry. This
DOCSIS, is it DOCSIS over glass?
Maybe I don't know. I never saw the abbreviation, but I can answer the second part of the question. So we do have this the virtual cable modem notion that Brady showed you. It's a logical abstraction that we instantiate for every physical ONU connected if operator decides to choose DPoX, the DOCSIS provisioning of any kind of PON. So that's not a hard requirement. You can also provision ONU in a telco style, but this really made by following the virtual cable modem approach, we keep the integration with the existing DOCSIS back office seamless. So yes, there is a virtual cable modem instantiated for the purpose of pulling out the config file over the TFTP from the DOCSIS provisioning system. And you may use the QoS information without service class names, or you may use it with service class names. The system will recognize it, and as long as you have the right service class name configured on the CMTS, it will recognize it and it will apply QoS parameters to the ONU. And so the traffic, I guess that's it. I think that the question should be answered by now, other than the DOG part.
Yeah, and he did follow up and say, yes, DOCSIS, DOG is DOCSIS over glass. And I remember that as I believe a Cable Lab specification that quite a few, probably a decade ago. But I don't remember. It was kind of like the same time as DPoE was being worked on, but I don't remember where DOG went. And I have not heard the term DOG in a long time. So thanks for bringing that up, Kai. Would be interested where DOG is. I'll have to research that and see if it's being used anywhere. And Kai would probably know because he's deep in this area. So Yeah, he says thank you. So I think we answered his question. So yes. So anything else? I think we covered everything we had planned to cover today.
I think so. Yeah.
We got. I think so. We got the rest of the question that got cut off before. Let's bring that question up so I can read it closely here. He said, "It's great to see more options like this come in to give cable operators more options to push new services out incrementally with systems they're already using." And I couldn't agree more. That's why I got so excited when Andrii talked about this. And he follows up. It'll be interesting to see how these options get used. And you mentioned the node splits. Like I didn't even think of the possibility of node splits. So yes, I think people will find different ways of using this. Kai followed up and he says that CommScope had DOG systems, by the way. We had some of their gear in production years ago. So yeah, it's like I think this was older technology that may not have really been propelled to today. So thanks, Kai. Thanks for following up on that. So I figured you would know, man.
Yeah,
all right.
I learned something today.
Yes, we're always learning. So all right. Again, Andrii, thank you so much. That wraps up our live demo of turning a vCMTS into a working OLT with a real PON network. And yes, it actually worked. Huge thanks again to Andrii, Vladyka for walking us through the setup, and also to Mia Calabrese for running the show. We got one more question to squeeze in from Michael Stark. Thanks for joining, Michael. Is the virtual PON MAC address generated based on the PON serial number?
Oh,
Yeah.
I believe so. So on the DHCP side, you can keep it simple and we'll generate MAC based on the serial number, I believe. Or we can insert another DHCP option that will have the serial number itself, or the serial number of the ONU. For this demo, we didn't get that deep because the original provisioning DOCSIS cable modem file work just fine. But if that's something you want to do, like rely on a serial number instead of MAC address, that's also possible with a different DHCP option.
All right, very good. So if you found this session helpful or just plain cool, give the video a like, hit the subscribe button, and drop your questions in the comments below. I'll be keeping an eye on them. So until next time, we'll see you in the next stream, and take care all. See ya.
Thanks, Brady. Bye.
Thank you.